Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, regarding this frame, so this is video number 10. So for video number 10, I actually will focus on how to draw the bending moment diagram for this frame. So this frame, we actually have analyzed this using moment distribution method. So there are four main steps. So discussed on the nine video, the nine previous video. Okay, now from the final end moment that we get from step number 4, we will draw the bending moment diagram. Okay, so this is the frame. Yeah, this is the frame, and the final end moment that we get is this. Okay, wait. Okay. So this is actually the frame and the end moment. Okay, we will focus on the final end moment. The final end moment for AB. Okay, for AB, it is negative 13.386. For BA is negative 1.183. For BC is 1.183 positive. CB is positive 118.907. CD is negative 18.907. And DC is negative 13.243. Okay, so how to draw the diagram, the bending moment diagram using this end moment value. Okay, so actually the process is very simple. So I will draw the diagram element by element. Start with member AB. Okay, for member AB, this is member AB. For member AB, the moment is negative and negative. Okay, if this is A, this is A, this is B. Okay, the moment, okay, we just need to focus on the moment direction, because the moment direction will show us where is the position of the bending moment. Okay, for example, for member AB, the moment at A is negative. So negative and negative, negative and negative, negative and negative. This show that the the position of the bending moment. Okay, we just need to follow the arrow. So point is here. So this is actually the bending moment diagram for member A, B. Okay, so this one is negative, negative. This is negative, and this is positive. Okay, so this is the negative value. The A value is 13.386, and for BA is 1.183. Okay, so in the diagram it is positive, because whenever the last position must be 0. So this positive we will plus with this positive, negative, so we get the final, the last point will be reach 0 again. So this is actually the bending moment diagram for member AB. Bending moment diagram for member AB. Okay. Okay, now Okay, we will do A, B, and C, D first because there is no external loading on the member. We will do member B, C later. So for member C, D, so we just need to look at the C, D, and DC value. It is column. So column C, D is like this. So this is C and D. And now look at the moment direction. It is negative, 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 and negative. Okay, means that the point, okay, we will draw based on the arrow. So we have this like this, and we just need to join this dot. Okay, so negative here, this is negative, this is positive. Okay, this negative we get from this value. Same for AB. So the negative we get from this negative. Okay. And then the value is 18. The value is 18. This is 18.907 and 13. This is 13.243. Okay. This is positive because when we plus with this negative, we get back to 0, which is the last position. Okay, now we are going to draw the bending moment diagram for member BC. However, we look at the diagram, member BC is subjected to UDL. UDL means that maybe it has maximum moment in the diagram. So maximum moment in bending moment diagram, we calculate from shear force diagram, the area of shear force diagram. So we have to draw the free body diagram for element or member BC only. Okay, so the free body diagram for member BC is like this. This is UDL. This is V1, V2. The distance is 6.4 and 5. 6.4 meter. The moment is MBC and MCB. MBC is 1.183 positive. 1.183 positive. And CB is 18, also positive. 18.907. 18.907. So this is diagram BC. So from this diagram, this is the free body diagram. This is the free body diagram. So we have to calculate the VY and VY1 and V1 and V2 because this represent the shear value. So from the shear value, we draw the shear force diagram. We look into the shear force diagram, check whether the shear force diagram has intersection or not. If it has intersection, it means that there is a maximum moment in the bending moment diagram. So by having this diagram, we just need to use the static equilibrium, taking moment at one end. So this is B, this is C. Okay, so let's say we want to calculate, we want to take moment at B, take moment at B is equal to 0. So it is 1.183 plus 18.907. We plus 5 times 6.4 times 3.2. Okay, and we minus by 6.4 V2. And this is equal to 0. Okay, from this we will get the V2. So it's 1.183 plus 18.907. 907. It is positive, positive. We get from the table. We get from table. Positive, positive. Okay, and then we plus by 5 times 6.4 times 3.2, and we divide by 6.4. We get V2 is equal to 1.914 kilonewton. So V1 is actually equal to 5 times 6.4. So 5 times 6.4, we minus by 1.914, 30, 0.86 kilonewton. Check again. 1.813, no, 1.183 plus 18.907 plus 5 times 6.4 times 3.2, 1.183 plus 18.907 plus 5 times 6.4 times 3.2. We divide by 6.4. It is 19, not 1, 9. It is 19.139. 139, so minus by 5 times 6.4. So it is 12.861. Okay, so what does it mean? So the shear force diagram, okay, is V1. V1 is 12.861 and V2 is 19.139. So this is the UDL. This is 5 and 6.4 meter. So from this, we get the shear force diagram as, this is the shear force diagram. The value is 12.861 and negative 19. This is negative side, so do not put negative. So this is 19.139. So this is positive. This is negative. Again, this negative. Again, this negative. Plus this positive, we get back to 0. So start with 0 position. This is the second position. This is the third position, and the last position is 0. So there is intersection here, means that maximum moment occur at this position. Maximum moment occur at this position. So in order to have uh, to calculate the moment, the bending moment, we have to have the area of this shear force diagram. So we have to calculate the area of this triangular. So in order to do that, we have to find the distance. We have to find the distance, this distance and this distance. So how to get this? It is 12.861. We divide by 5. We get 2.57 meter, and another one is 19.139. We divide by 5, so we get this as 3.83. So in total 2.57, we plus by 3.83, we get 5, we get 6.4. We get 6.4. Because total length for AB, for BC is 6.4. Total is 6.4 meter. Okay, now we want to draw the bending moment diagram for member BC. So this is BC, UDL, UDL, this is 5 kilonewton per meter. This is 6.4. 6.4. And then the shear value is 12.861 and 19.139. And then don't forget to put the moment. The moment is 1.183. 1.183 and 18.907. This is 18.907. Okay, from this we the shear force diagram, okay, is like this. Shear force diagram. This is the shear force diagram. Shear force diagram. 2.57, 3.83. 2.57, 2.57, 3.83. The value is, this is 19.139 and 12.861. This is positive. This is negative. Negative. Okay, so this is shear force diagram. Okay, from this we will draw the bending moment diagram. So for the bending moment diagram, we put the first position. Okay, it will be located somewhere above line. This is the first value. So the value is 1.183 for the first moment value. And the last value will be below the line. It is 18.907. It is 18.907. First value, second value. So what is the value in between? Means at the intersection. At the intersection. So we will get this, okay, from the area of shear force diagram. Okay, so we will calculate like this. The first value that we should put is 1.183. Okay, this 1.183 is at positive side. We have to plus by area of triangular. So we have to plus 0.5 plus 12.861 times 2.57. Okay, we get the value equal to 17 positive. It is 17, okay, somewhere here, and the value is 17.709. So this is moment value. Okay, and then we have to minus 0.5 times 3.83 times 19.139. It is negative. We get negative 19, negative 18, negative 18.9, negative 18.9. So which is equivalent to this negative side. Why it is negative? Because this negative value, when we plus with the positive here, so we will get back to zero value. The diagram must close loop. So now we just need to join all this. And remember, for UDL, we will get bending moment diagram curve line like this. So this is positive and this is negative. So this is the bending moment diagram. Okay. So this is how we actually draw the diagram here for the bending moment diagram. Actually, for this frame, whenever there is no load along member AB and there is no load along member CD, we just draw the BMD directly. However, for member BC, since BC is subjected to UDL, actually in the shear force diagram for member BC, we can identify whether the BMD for member BC has maximum moment or not. We will get the maximum moment uh, which is occur at the intersection in the shear force diagram. Okay, hopefully it will help you to draw the diagram. So that's all about this example and solution. I have made 10 video regarding this, so I hope you will try to do on your own. Okay, so actually I want to actually do some video regarding the bending moment diagram. I've done few question and solution, and I will focus on how to draw the bending moment diagram for all example and solution I have done. Okay, so we will meet again insyaAllah in the next video. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.